So, myself, Muhammad Hashim, I am a proud student who received internship training from Emextre. So, let's dive into our presentation, mastering IoT and Embedded system from conceptual level to practical development. These are the outlines of our presentation, and we will be diving into each one of them. So, let's unlock the power of IoT. The Internet of Things connects physical of embedded system with sensors, software, and network capabilities to exchange data online. IoT enables seamless communication and automation integration everyday things with the internet for smarter interaction. Devices range from household application to industrial machine support devices diverse application across sectors. Supports real-time monitoring, data collection, and control to improve operational efficiency. Drives smarter infrastructure, optimized resource management, and enhanced user experiences. Let's look into the key IoT features driving intelligent systems. Harnessing real-time data and remote control and automation to enhance connectivity and power efficiency. Real-time data acquisition and processing enables immediate response and informed decision-making across devices. So if we require real-time data acquisition processing, such as in our case, we will be using in automation, home automation. So there we require real-time water tank level and the temperature in order to process them and adjust the air condition accordingly. And there is remote and control and monitoring systems which allows users to manage devices from anywhere, improving convenience and safety. So we will be requiring systems which need to be in remote places to collect data such as light intensity and tracking, stars, etc. Then there is automation, which reduces manual tasks, optimize operations, support predictive maintenance to increase efficiency. We can use these IoT features to automate our systems efficiently and connect them to our internet to monitor them easily. Together, these facilities enables intelligent environment in homes, industries, and smart cities. Let's understand key IoT architecture layers. Perception layer. For this layer will be the layer where we will be collecting data from sensors and devices and using various sensing technologies. Physical data such as distance, temperature, air, humidity, pressure, light, etc. And then the network layer where these percepted layers will be transmitted to our application layer or any storage systems, and this transmitted data will be through Wi-Fi, Bluetooth or cellular network. In our case, we will be using an Ethernet data. And there is the final layer, application layer, processes and analyze data to deliver tailored services like smart home control, industrial automation, and other IoT applications. Now, let's look into power and industries where we will be using IoT. Smart home enhances comfort and security through devices like thermostat, lighting, and security systems. Wearable monitor health metrics supporting fitness tracking and medical monitoring. Industrial automation uses IoT sensors and actuators to optimize manufacturing processes. Predictive maintenance leverages IoT data to reduce downtime and enhance equipment reliability. Supply chain management improves efficiency and transparency using IoT-enabled tracking, such as banks uses them to check the transactions done by a user or client. These applications showcases IoT transformative impact on daily life and industrial operations. These are the key applications for which IoTs are used, and there are also many more for which we will be understanding later. So let's understand embedded systems. Embedded system is specialized hardware and software powering real-time and dedicated functions with limited memory, power, and resources. Embedded system combine hardware and software designed for specific tasks within larger systems. So if there is a larger systems which perform simple tasks, so example excavator which digs, we can automate them using hardware and software with the help of embedded system. They enable real-time data operations and dedicated functionality critical for device performance. Common examples include automatic control unit, home applications, and medical equipment. In our case, it is home automation, where we will be using Arduino Uno as our embedded system and other sensors like cooler, temperature sensor, volume sensor, and the LDR sensor, which helps us to turn on the light on off according to the intensity of sunlight. These operates under constraint of limited memory processing power and energy consumption. These systems are essential, requiring reliability, efficiency, and tight integrations between hardware and software. So, for our project, we will be using them together to complete our project. So let's dive into the 4 key types of embedded systems. There is standalone system which operate independently without needing network interaction, suited for isolated tasks. So if we have any tasks which are in an isolated places, such as monitoring your agricultural field or anything, we can use the real-time embedded system delivers timely responses with restricted deadlines and essential for safety critical environments, such as fire detection system, which uses real-time safety checking embedded systems, which will give critical responses for them. Networked embedded system communicates with other devices for central systems to enable integrated coordinations. Today, our smartphone, laptop, computer, PC, smartwatch, earbuds, etc. all are connected to form an ecosystem. These are called networked embedded systems. Mobile embedded systems are portable and battery powered. Examples like smartphone, wearable, designed for mobility. So any devices which are portable and has a built-in battery, they are called embedded systems. Identifying these these types of enhances selection for the right embedded system architecture. So if you want to build a system, and we can select this embedded system according to the natural system. So if we want to control our home automation, we will be using a smart, real-time, standalone, and the network embedded system. They can be together in one tool. Now look at the core components of our embedded system. There is hardware, which is the foundation of embedded system. We include sensors that detect environmental input, incorporate actuators to perform physical actions. This uses microcontrollers to process signals and control devices. Application software executes specific embedded tasks, runs tailored programs designed for dedicated functions, interfaces directly with the hardware to manage system behavior, ensure application-specific performance, reliability, real-time operating systems, manages, optimizes operations, control, hardware, resource allocation for efficiency, schedules real-time tasks, ensuring predictive execution and maintenance, system response crucial for embedded environments. So, our embedded system for which we having a hardware and application software. Together they will be forming to make a real-time operating system to manage and optimize our operations. So how are we using embedded system for our everyday devices? In cars, they will manage engine control, safety, and driver assistance. In my case, I have a motorcycle which uses traction control and ABS. These are designed by embedded system which will give real-time responses to the ECU, which will understand and view the emergency and safety systems accordingly. Washing machines have automatic washing cycles for efficient cleaning, and digital cameras have image capture and light capturing and other automatic functions. Smart devices such as thermostat and home assistant enabling automation control. In today's homes, they have a smart Alexa or other embedded system for which we can directly talk to AI assistants and control our home devices efficiently. These embedded systems operate seamlessly to enhance device performance and user experiences. Now let's look into mastering Arduino IDE, simplifying embedded programming. So what is Arduino IDE? Arduino IDE is an integrated development environment which we will be using to program our embedded systems. This is a user-friendly code editor which facilitates writing and editing Arduino sketches. Arduino saves their files as in Eno format, which we can open using Arduino IDE software. There is a compiler which converts the written code into executable instruction for Arduino hardware or any devices which can be operated using hex file. The compiler converts the Arduino Eno or any C programming file to a hex file which contains combinations of zeros and ones as binary. The uploader transfers the compiled program directly to Arduino board with ease. Arduino IDE also supports diverse functions enabling development across many embedded device system projects. So not only we can use Arduino to IDE to performs only on Arduino, but also other microcontrollers such as ESP32, Mega, Micro, Pi, and many more. This is a widely popular software among learners and professionals due to simplicity and its versatility. Since Arduino IDE uses simple C programming and C++, these are widely accepted and has a huge fan base. Now let's master how Arduino IDE's workflow. We write a source code and where we will develop a program according to our need, and we will write into the editor and using various libraries and their complex hardware integrations. Then we will compile this code and convert it into source code with made to machine readable formats such as binary code or hex files format through Arduino IDE's compilation. Then we will upload to the board and transfer the compiled code to the compatible board like Arduino Uno or any microcontroller for execution and a rapid prototyping. So for our project, we will be using FixingLab. Let's understand what is FixingLab. FixingLab is a real-time Arduino emulator or any microcontroller emulator, streamlining, debugging, and testing for efficient hardware deployment. So before destroying or damaging any physical hardware, we can use FixingLab to test this filthy or good code and check them whether they perform correctly or not. This provides real-time emulation for Arduino development boards and enabling virtual project simulations. This also supports peripheral simulations to mimic hardware behavior without physical components. Also offers interactive interfaces to test and modify embedded code dynamically during simulations. Facilitates smoother hardware deployment by validating code integrity before physical testing. Enables early debugging and issues identified to save time and reduce source cost. So this helps us to save costs and protect us from any hardware damages before implementing these codes, which may have been corrected or has any error. Now, why we are using C for our IoT innovation? C programming is an efficient hardware control enables direct manipulation and embedded system components, boosting device performance. Optimized performance critical for IoT devices with limited resources, ensuring fast processing and lower power consumption. Portability across platforms supported by widely spread C compilers, enabling IoT applications on diverse hardware architectures. Foundation of embedded systems, making C indispensable for developing reliable and source-aware IoT solutions. C programming is essential in overcoming tight resources constraints typical to IoT environments. So, in IoT platforms, it is typical that the resources are constrained. So, having C programming, which is directly between hardware and the chip level design, C can work very well than other codes. So what are the core elements of C programming? There are character sets, identifiers, keywords, data types. Character set defines all valid symbols, including letters, digits, special characters used in codes. Identifiers names for variable, function, other user-defined elements following specific naming rules. Keywords reserved words like if, return, while that have special meaning in C syntax. Data types built-in types such as int, float, char that specify variable storage and their behavior. Mastering these fundamentals enables clear, structured, and efficient programming. So let's master the essential C concepts for embedded systems. We will be using operators, arrays, pointers, function, conditional statements, storage classes. For arithmetic and logical operations, operators are used to perform other operations such as arithmetic operations such as addition, subtraction, multiplication, division, modulus, etc. Arrays are used to store and manage a sequential collection of elements and efficiently. So arrays help us to store these elements such as characters, numbers in sequential manner, and we can perform push and pop or FIFO functions to insert or retrieve them easily. Pointers providing direct memory access for precise control over embedded hardware. So pointers help us to point to the address where the hardware can easily retrieve the data efficiently. Functions to organize code in reusable modular blocks for maintainability. If we want to use the same code for any other process, we can create a function and put the code in there. These functions can be called in anywhere according to their specific requirements. Conditional statements managing program flow with the decision making logic. Conditional statements such as if state and else and many while statements such as and many switch statements. We will be using them in our program to only do a function if the condition is satisfied. Storage classes define variable scope and lifetime for efficient resource management. Storage classes such as public, private, external, and global. We will be using them in our project to call them in different header files. These core elements form backbone of sophisticated high-performance embedded software development. Dynamic LED control driven by LDR sensors. In our project, we will be using an LDR sensors to control the light intensity of an LED. LDR sensors light-dependent resistor changes its resistance based on surrounding light intensity. Microcontroller reads analog signals, captures the variable resistance through analog input to evaluate current at high level. The microcontroller processes the data and it interprets the resistance value and determines whether the LED should be on or off. So the LED state is adjusted based on the light intensity and the resistance value data taken from the LDR sensor. Now let's master LCD integration. Initialize C LCD display. Let's set up the microcontroller pins and configure C LCD timing and control signals for reliable text outputs. Writing text to LCD. We use sequentially to send the data into the LCD and they will display it on desired message on the character LCD. Establishing serial communication. Configure for serial port parameters such as baud rate, bit rate, parity to enable device communication for tank control. Transmitted tank data. For the serial communication such as data, tank volume, send sensor readings to the control command through serial interface to monitor and regulate tank levels and fluid flow. Receive and process feedback. Use serial input to update display status and adjust tank operations based on the incoming data. So in our project, we will display the tank volume and temperature readings on our display. Also the status of whether the inlet or outlet valve is on or the heater or cooler is on or off in our LCD display. Now let's master device control with the Blynk IoT platform. So what is Blynk IoT platform? It is used to seamlessly connect, customize and monitor IoT devices via mobile apps. It is a mobile-based platform enabling easy control and monitoring of IoT devices via smartphone apps. Customizable. It has customizable dashboard which allows users to tailor, control and visualize for each devices. Support device connectivity through Wi-Fi and Bluetooth for flexible wireless communication. In our case, we will be using an Ethernet shield to connect our device to the internet. The hardware integration connects devices to Blynk's cloud services for real-time interactions. We can use switches to turn on or off the heater or the cooler, and also switch to turn on or off of the inlet and outlet valves of our water tank. And also we can read the data of how much temperature it is and also the volume of the water. This also demonstrates showcase Blynk's user-friendly interface and rapid development of our embedded projects. Not only the Blynk app is user-friendly, we can also easily adjust these projects and switches to control our embedded systems easily. This is ideal for embedded IoT applications requiring remote control and distance feedback. In order to automate our process, Blynk app is the perfect solution for our project. Now let's look into how we implement our project. For this, we will be using Arduino Uno in PixinLab simulation and also Blynk app for smart app-based control. For that, you will be using the components such as Arduino Uno, serial, tank, temperature system, LDR lighting system, Ethernet shield, Blynk app, and an LCD display. So, what is Arduino Uno? It is a microcontroller which we will be using for our project through PixinLab, which is user-friendly, beginner-friendly, and prototyping in electronics and IoT applications. It is based on 80 mega 32.8p microcontroller and offers an accessible platform for coding and hardware interfacing. If we look at the picture, we can understand how Arduino Uno is shown in PixinLab. We can see it has a power reset button which we will be using to debug our microcontroller, and there is file where we can save, load, and use the X file, and also configure the ports of our microcontroller. And there are boards where we can use different microcontrollers, not only Arduino Uno, Mega, ESP32, and many more. And there are microcontrollers where the main component motherboard of our system will be selected. Then there are modules where we can use spare parts to connect heater, temperature system, and other modules. Then there is tools from where we will be adding serial tank. Now let's look at the components we have used in our project. As you can see, there is a liquid crystal display, and to drive that display we will be using a PCF8574 driver. There is a LED system which is available in PixinLab, which we will be using to garden our light, and this is a LDR sensor which we will be using to control the LED, garden LED. We will drag this lever to up or down to control the resistance of the LDR resistor, which will control the intensity of the light of our LED. This is the temperature system which we will be using. Here we have a fan which will cool the temperature, and also a heater which will increase the temperature of the system. This is the Ethernet shield which we will be using to connect our automation to Blynk app. And let's dive into how we implemented this project. Now let's take a look at the Blynk console. The Blynk console is useful to control, create Blynk app automations. So here we will create a device in which we will be using adding data streams. These data streams will be shown in the Blynk app. We will create each data streams using editor, and we will add them and add values to them, and we will apply and save changes in here. Now let's look into our ports which we used to drive our automation. Okay, this is the automation port which we will be using. There is home automation port using Blynk controller. For this we have defined many things here. As you can see, cooler, pass-set, digital write, digital read, and many more. This is LDR files. This is LDR header file. This is main file. This is serial time C writing file. This is serial tank header file. This is temperature system embedded file, and this is the handle temperature system header file. We will be using these codes to control our entire embedded system. After writing these codes, we will verify them and using this tick logo. After that, we will this is also used to combine this and the output will be shown in here. If there is any error occurs in the in our programming, it will shows here. We can check the error from here and also correct them by analyzing them. After that, we can upload it through here. In order to upload the code, we need to select the microcontroller which we will be using. Here we can select many microcontrollers and devices to program them, and we can also select serial ports from here. After compiling and uploading them, we will be using our Pixel Lab. So this is the microcontroller which we will be using. This is an Arduino Uno. It has 13 pins out of 8205 is analog, and these are digital pins. There is serial data pins and a ground pin, voltage pin, reset pin, and many more. Will be, and it is configured to. I have configured to the port, and we will be using this. And to show how it works, we will be using the spare parts which I shown here. So as I shown before, this is the system which we will be using, and so you can see there are many readings. So let's implement our project. So this is the serial tank which we will be using, and now let's connect our system. Okay, let's start our program. Okay, where it shows, it is showing us that our system is working perfectly, and you can see the water is filling tank. You can see the water is filling, and it shows water is filling on. Also, you can see it is successfully connected. Now let's control our garden light. So you can see, as I am decreasing the resistance value, the light is dimming, and as I am increasing the light, it is increasing the intensity of our LED. Now, how do we control this system? As I have shown you, this is how our tank is filled. It is now full, showing it is 3000 liter full. So let's keep it here. Now, how do we control our temperature system? Let me show you. As you can see, this is my smartphone interface. We will be controlling our phone from here. Now let's open our Blynk IoT app. As you can see, there is an interface for us to control. And as you can see, the inlet valve of our tank is on. So let's off it now. So here you can see the inlet valve has been off. And now let's open our outlet valve. As you can see, our tank is outlet valve has been off and it is emptying, and you can see the volume is reducing slowly in our mobile app and also on our system. Yes. So there is an soft condition: if the water level has been reduced to half, the tank will automatically fill it. So if I turn off the outlet valve, it will fill it automatically. Okay. Now let's turn off both our inlet and outlet valve. Now how do we control our heating systems? As you can see here, it shows how the systems of how whether the inlet valve or outlet valve is on or off. And now let's check whether our temperature is increasing or not. So let's turn on the heater. As you can see, the heater is on and the temperature is rising here, and it is shown on our system. So after reaching a certain temperature, it will automatically turn off in order to not overheat the environment. Now let's turn on the cooler. Okay, now the cooler is turned on. As you can see, the fan is running and the temperature has reduced to compatible condition. So this is our system. As you can see, we can turn on and off our heater as we want. Also, we can turn the inlet valve to fill the water, and turn on the outlet valve to empty the tank. And you can see the all status from our little display and through our phone too. So this is our project, and this so thank you and have a nice day.